Today, we'll continue our discussion of interfaces by introducing Fitz's law and discussing some common pitfalls in interfaces and interface design. So Fitz's law is really just this idea that you want to make the easy to access things bigger and the less often, or maybe things that you want people to access less, things smaller. So, one example is car brake versus acceleration, right? That's on the left there, right? The brake pedal is usually, well, it is always bigger than the accelerator pedal because you don't want to accidentally, if you need to brake, you need to brake, right? You don't want to accidentally hit the accelerator while you're going for the brake, right? Similarly, on, let's say, big industrial machines, usually the on button, right, is on the right here is really small, whereas the off button or stop button is usually really big because you want to be sure somebody really wants to start like a big piece of equipment, big piece of machinery, and then if you want to stop it, you want to make that very easy to do so that people can hit that target. So there's a video linked here, and you can find it in the notes below or in the Blackboard Learn slides that goes into a little more detail about this. But what Fitz's law comes down to is really, it's about the amount of time that it takes to hit a particular target, whether that's something you actually touch or press, or whether you're trying to get it with a pointer, let's say a mouse or a trackpad. And that has to do, of course, with how far away that target is and the size or width of that target, right? Again, if it's close and big, that's an easy to hit target. If it's farther away and big, that's a little bit less easy to hit, but still easy to hit. If it's far away and small, right, that's a much harder target to hit, right? So there's actually an equation that describes this, where, again, these parameters A and B are used to kind of fine tune this in different situations. But you don't really have to worry about that so much, but just understand the principle. Take a look at that video and try to understand the principle and how it applies to our interfaces, right? So here's a screenshot of Windows, or at least a semi-recent version of Windows, Windows 8 apparently. But Windows has a certain philosophy around every window is going to have its own menus, right? So where is the file menu in Windows, right? Well, it's always at the top left of the window, right? Now, again, that's great for consistency, and we'll talk about consistency in a second as well. The only downside is that that your windows might be in different locations. So that file menu actually moves around depending on your window. And again, people get used to that, and in some ways it's easier because if you're looking at or working in a particular window, you want that file menu to be close, to be accessible, right? Whereas Mac OS has a different philosophy, right? Mac OS says that the menus are always going to be at the top, and really that the file menu will always be near the first non-application menu to the left, right? So it's always in the same location. So here they've really tilted it in favor of consistency across all applications, right? No matter what you're doing, that file menu will always be in the same location. So both different applications of Fitz's law, right? With, again, that sort of lead users towards different behaviors. So let's think about this in terms of something you actually touch, like your keyboard, right? So by Fitz's law, what you want to do is minimize the amount of movement that it takes to complete certainly very common tasks, right? So what I'm thinking of right now are the keyboard shortcuts, like save, right? Which, depending if you're on Windows or Mac, might be Control S or Command S, right? And you can see, or select all, right? Control A or Command A. And you can see that those are mapped to very common keys, right at the center of the keyboard where your fingers are likely to be. Right? So if you want to do select all, that's a Control A on Windows, right? And that's a pretty easy thing to do. You can sort of do it with one hand, although a little bit harder to do, right? because the control key on again, a lot of keyboards, certainly on this keyboard, there's only one control key. But and so you kind of have to sometimes, and it's in kind of a weird position, especially if you're trying to do something all with your left hand. Um, this is the reason on the Mac, right, that you use the command key instead, and that the reason Mac keyboards have two command keys, so that you can do that with your thumb. And if you just look at it or try it on your keyboard right now, it's a little bit less awkward to do that with one hand without actually having to like hit control with your left hand and then take your right hand and do control A or control S, right? On the Mac, you can do that with all just one hand, right? Now, on the other hand, Mac isn't always better. Windows has many more keyboard shortcuts to moving around dialog boxes, using tabs and arrow keys. The Enter key is separate from the Return key, things like that. So in fact, Windows is designed in such a way that you don't even need a mouse. You can actually do almost everything. I think it's true that you can do everything just from the keyboard, right? Whereas on a Mac, you definitely need a mouse for certain types of things. Another interface that you're probably very familiar with is the car, right? Our car, steering wheel, steering column. And of course, in more modern cars, we started to see more and more controls right on the steering wheel. So, here under your left thumb, you can control the volume, change the source of your audio, and actually move around a menu, right? This is a relatively recent thing, right? I mean, it wasn't until, maybe like, cars are, more than 100 years old, but it wasn't until about maybe 30 years ago that we started to see these kinds of on the steering wheel controls. And again, that is a natural thing because otherwise you would have to take your hands off the steering wheel. You have to make a big movement to find a control that might be small or even difficult to find, if you want to change what you're listening to musically. Here you can leave your thumb leave your hands and your thumbs right on the steering wheel, change volume, change track number, change source, that sort of thing, right? And more things are being added onto the steering wheel as well. I find car interfaces to be a really fascinating area because there's where a lot of experiments happen, like things like this, where you put buttons on the steering column, and of course, then you have things like the Tesla Model 3, where most of your controls are just on a big touch screen, right? You have a steering wheel, but beyond that, almost everything is a touch screen, which provides a lot of flexibility, but again, requires you to do movements while you're driving, kind of, against Fitz's law, and sometimes trying to hit targets that you can't feel, you can't find them by feel on a touchscreen, right? You actually have to take your eyes off the road, and potentially dangerous situations there. So, but I think with cars, there is a great deal of experimentation and innovation that happens around interfaces. Not everything has to be a screen. Sometimes having buttons and thumbsticks, essentially a D-pad, can be the best interface, especially when your attention should be focused elsewhere. So with that leads to a discussion of some common interface design pitfalls, right? I've said this before, that like a good interface can make it feel like you're kind of coasting or going downhill, whereas a difficult interface or a poor interface can make it feel like you're constantly pedaling uphill, right? So one of the most common things, whether it's cars or computers or devices, is creeping featureism, right? Meaning that, yeah, these things are getting more and more capable. There are more things that we want them to do. Your car, as you're driving a car, you're also sort of controlling a computer that can tell you, about navigation. It can tell you, about music choices or listening to the radio, that sort of thing. You're adding more and more things, right? And this happens in every type of device where you want to add more features, and it tends to then add greater and greater complexity, right? Even if the original version, right, car, steering wheel is a very, very simple and elegant, straightforward kind of thing. But you start adding more and more buttons, and at a certain point, right, it's too many. You're trying to accommodate too much with the same controls. So, but this is a very, very easy thing for people to fall into. I mean, I'm sure you've seen it on remote controls. If you buy a modern TV or a modern entertainment system, you probably get a remote control that has a million buttons like this. Or again, I've gotten TVs where now it's just an Android tablet, right? Or again, they've got a lot of functionality, but now you're holding a computer without any buttons without any physical buttons. So now you need to look down at it to like change the volume or change the channel. And that seems less than ideal as well. Right? Of course, this idea has been made fun of in popular culture. There's a Dilbert cartoon, right? Which is all about, hey, we need to add more features. Just need to add more features. Here's a quote about creeping featureism, where it's kind of this disease that needs to be fought against, but really that the best approach is to just try to prevent creeping featureism. This quote is from Don Norman, and why Don Norman is kind of important is he literally wrote the book on sort of interface design, not just for computers. I mean, he has a background in computer science, but really his focus was on comes from this book called The Design of Everyday Things, which is kind of the canonical textbook in the product design world. Not as many engineers read this, but I wish they would. And Don Norman has a tremendously diverse background. His background in electrical engineering and computer science, but also in psychology. So really invented this field of sort of what is good user experience, user design, not just for computers, but for everyday devices. So I highly recommend this book. It is not expensive or anything. It's very common. It's paperback, so and certainly well worth a read. People who don't follow that advice will easily fall into really, especially on computers, ridiculous interfaces like this. This is an old Windows utility for renaming files, but oh my God, how can you possibly navigate this or learn to use this interface, in an efficient way? There are just way too many options, way too many places to make different choices there. Not just in software, though. In the computing world, there have certainly been hardware products, right? Way too many buttons. Look at this mouse, which has 14 different buttons on it, and not in a particularly good way, right? That there are probably better ways to integrate more controls on a mouse, right? We've seen that with a couple buttons, maybe a scroll wheel or a scroll pad, maybe something around the thumb. This mouse was designed for lots of different commands for Open Office, which was an open source competitor to Microsoft Office in the old day. But it's just nuts. It's crazy. And in fact, the people who made Open Office kind of disavowed this mouse, saying that, no, that wasn't us. That's not what we were designing for. Right. So again, this idea that we need to do more, just by adding more buttons or more controls, creeping featureism, that's always something to be on the guard against. Right? A lot of times interfaces need to be redesigned if you're going to add more functionality. The second pitfall I'll talk about is something we call skeuomorphism. Now, what skeuomorphism is, and this was a big, big trend, and fortunately it's sort of backing off, is that we need to design things that mimic what they look like in the real world. Right? So this is an interface from a piece of software, a digital audio workstation, right, where you can do music recording, right? And there's this huge trend, and arguably it started here. I actually used to work for a company where we made digital effects and built these interfaces. And we thought it was really cool that we could say, hey, instead of using that rack mount gear that you have, that physical box that does an effect, we're going to replicate that interface in software because, we know you don't know how to use it, as a separate box, but, we'll make it familiar for you. Well, at a certain point, it becomes ridiculous because why would you have round knobs on screen when you don't have a round knob controller anywhere, right? What am I supposed to do? Am I supposed to click on that and then sort of spin my mouse in a certain direction or rotate, the coordinates of my mouse? It ends up being crazy. And then people do crazy mappings. that you click on the wheel and then just move up or down, and that rotates the wheel. And there's never consistency around that. But so in the actual controls, the sort of adherence to the physical world can get to be absurd, right? And fortunately, this is, aside from, for some reason, audio production tools, this is a trend that's sort of diminishing in other areas, right? We used to see that a lot more in aspects of common apps like the calendar, right? This used to be the calendar on Mac OS, which we had the fake leather at the top just to make it look more like a desktop calendar, as if people couldn't figure that out from the interface itself. The iOS podcast player, when it first came out, had this kind of funny interface that, again, was a nice throwback for people who understood what it was. But if you didn't grow up in an era of tape decks, particularly reel-to-reel tapes, you probably didn't know what this thing was or what it referred to. It's just like, okay, that's a weird interface, right? It used to be that we recorded onto magnetic tape, recorded audio on a magnetic tape, and you'd actually put those spools of tape on a player and have to wind that tape through the playback mechanism, and so that it would then spin onto another tape. I know, crazy. It seems like it's barbaric, but they made the first podcast player had an interface like that to mimic that, and just wasting a lot of space for that kind of silly nostalgia or silly animation, right? One of the early book library or book applications, right, on the iPad, had this fake bookshelf. Again, maybe that made sense, but it was kind of ridiculous and over whatever. It kind of tries to hit you a little bit too much over the head with, oh yeah, this is a wooden bookshelf, right, as opposed to just maybe a list or just book covers, which is what it is now, right? Of course, there are times where the physical object, right, has a lot of complexity to it that then, again, may have made sense at a particular time. This is a physical analog synthesizer where you can connect with these cables different parts of the synthesizer together to create different sounds. Again, that may have been useful for a particular time. In fact, it harkens back to the original way we programmed computers, by physically connecting cables, or even going back to the way that we would connect phone calls, where operators actually physically connect or patch one call into another to get people to be able to talk to one another. But again, that adherence to the physical object can certainly go a little too far. That here's a computer interface, right, in a program called Max that tries to give you that kind of patching capability that in old music synthesizers, but where, again, it introduces a tremendous amount of complexity and confusion in how those patches connect and where they go. And again, it's another thing where, after you've specialized in this for a while and have worked with this, you can get to learn it. But to somebody who's untrained or seeing it for the first time, it can be incredibly dense and incredibly confusing as well. So so there's an enormous trade-off with that. Sometimes the physical analogy may help you understand something. Sometimes it can just lead to greater confusion, and maybe we should rethink how we do that. Maybe there's a better, more efficient way to do that, especially on a computer screen. So let's see, I've talked about the creeping featureism, skeuomorphism, and then the third sort of big pitfall is just simple inconsistency, right? Inconsistency across an interface. And you will find inconsistencies everywhere. And most of them aren't fatal. They're just a little bit of extra work that you need to worry about, right? So a classic one is on the iPhone, on iOS, right? They changed the shift key, right? That's behavior, it's highlight behavior. So can you tell from these two screenshots, in which case is the shift key active, right? If you've gotten used to it, you probably do know that it's actually the one on the left. But the one on the right could equally be. I mean, the color actually matches. The color is differentiated on the right. So why wouldn't I think that normally the shift key is white, and when I highlight it, it becomes darker. Right? So weird inconsistencies like that. Some of these inconsistencies are just baked into how we've used computers in the past. Right? So, when touchpads first came out, trackpads first came out, right? We followed mouse conventions. So if you want to scroll down, you would just, move your finger down on the screen. But then when multi-touch was introduced on phones, right, we reversed that. Why? Because if you think of it as more like a sheet of paper, you want to move the paper up so that you can see what's at the bottom part of it, right? So this sort of scrolling inconsistency, again, this is now still a setting, right? That you can set on your computer, or not so much on your phone usually, but on your computers. And there are some people who will just never, never accept a change in that, because it's just been so culturally ingrained in their habits. So sometimes it takes a bigger shift than something that is more more widespread or sort of natural in interaction, and you have to overcome those sort of historical cultural barriers. So I always find it interesting to ask the class. I mean, obviously I can't ask you like this, but maybe we'll talk about this in class. Which direction do you use, and which do you find more natural on your computer? All right, so that's it for Fitts Law and some interface pitfalls. We'll have one more topic on just looking at sort of human-centered design before we wrap up interfaces, and that'll be our last topic for the class. I'll see you one more time.